Moai statues of Easter Island. You are standing on a wind-blown ridge, and huge stone faces fill the horizon, eyes fixed toward the sea. Each figure can weigh as much as 80 tons, and some stand taller than a 2-story house. Carved from volcanic tuff, they were shaped at a quarry and then taken across the island. For a long time, the idea of hauling such weight with simple tools seemed impossible. Recent experiments changed that view, but left the mystery alive. Scientists recreated a method where small teams used ropes and a rocking motion to make a statue move upright, almost like coaxing a giant to walk. Those trials showed the islanders could transport these figures with surprisingly few people and without advanced machines. The statues were designed with a forward lean and curved bases, features that made the walking motion work. Roads on the island also helped guide each heavy shape along a planned route. Still, the practical answer is only part of the story. Why build so many enormous stone heads in such a short span of time? And why place them staring outward in precise ceremonial sites? The construction speaks to deep social organization, to craft skills, and to belief systems we only glimpse. And even with a working method, the scale of effort and the cultural meaning behind it remain questions. How did a small island society coordinate such massive projects, and why devote them to those faces? You might think the moving trick answers everything. It does not. Archaeologists found roads, quarry marks, and village sites that show organized crews and planning. The statues were not solo projects. Teams carved faces at the quarry. They prepared paths, hauled stone, and built ceremonial platforms where the figures stood. Some of those platforms required precise leveling and huge stones set with care. They also added red stone caps to certain heads. Those caps came from a different quarry across the island. That means more travel and more coordinated work. For decades, scholars blamed collapse from overuse of wood to build sleds and rollers. New evidence complicates that story. The walking method needs ropes and skill, but far less wood than earlier theories assumed. Excavations reveal gardens, fish ponds, and sustained food production during the building era. So the image that a society burned itself out to make statues is too simple. The real mystery sits with purpose. Were the figures ancestor markers, trophies of rival clans, or political statements meant to be seen from the sea? Why were so many toppled before Europeans arrived? Was toppling part of social change, ritual conflict, or a deliberate shift in belief? The stones prove skill. The patterns show planning. But the why keeps slipping away. If a small island community could move giants with ropes and design, what did their beliefs look like that pushed them to invest so much in those faces? Antikythera Mechanism. You lift a green, crusty fragment pulled from a sunken Roman cargo ship, and inside is a tiny world of gears. At first, it looks like a damaged clock. Then, researchers cleaned it and found more than 30 interlocking bronze gears cut with uncanny precision. The device dates to around 100 before the Common Era. Turn a lost crank, and the gears would move pointers that tracked the sun and the moon through the zodiac. They could predict lunar phases and forecast eclipses. Inscriptions on the case even point to cycles used to schedule Panhellenic games on a 4-year rhythm. This was not a simple toy. It modeled irregular motion of the moon, the slow wobble of the seasons, and maybe even the positions of the visible planets. For more than 1,000 years, no one matched this level of mechanical skill. That gap is the core mystery. How did a workshop in the ancient Mediterranean produce gearwork that would not be seen again until medieval clockmakers? Some scholars point to known astronomers and engineers from antiquity as possible influences. Others say the device came from a lost tradition of instrument making that vanished with time. Technical studies reveal careful tooth profiles and complex gear ratios that imply skilled metalworking and deep astronomical knowledge. At the same time, the wreck offered no clear maker name, no workshop stamp, and no surviving manuals. We have fragments, an accurate reconstruction, but not the story of who designed it and why a single object like this was being transported on a merchant ship. Was it a custom commission for an elite patron, a teaching instrument, or a prized object of a civilization with hidden technical schools? It proves the ancients were capable of astonishing engineering. But it also leaves a sharp question. If they could build a mechanical map of the heavens, what other sophisticated skills disappeared with them? You trace a finely cut gear tooth and realize this is not a crude artifact. Microscopic studies show deliberate tooth shapes and careful gear ratios. Inscriptions carved on surviving fragments list cycles and provide language clues. Those markings match astronomical schemes known to ancient Greek scholars. Radiocarbon and stylistic evidence place the work around 100 years before the Common Era. Yet, the wreck that carried it gives no maker name and no clear workshop origin. Some experts argue the mechanism came from a tradition of Hellenistic instrument making centered in major cities. They point to known engineers and to textual descriptions of complex devices by ancient writers. Other specialists propose it was a rare, bespoke instrument built for an elite patron or a temple school. Technical reconstructions demonstrate astonishing accuracy in eclipse prediction and lunar modeling. Modern rebuilds using bronze and hand cutting reproduce its functions and show how precise craftsmanship must have been. The device also encodes cultural details like the cycle tied to Panhellenic games, which suggests social use beyond pure astronomy. That dual nature makes the object both scientific tool and cultural object. If it served teaching or ceremonial tracking, it reveals organized transmission of technical knowledge. If it was unique, it hints at a lost workshop with skills that did not survive wide copying. We hold a working model and readable inscriptions, but not the chain of makers and students that produced it. So the question remains. If a vanished tradition could cut bronze gears with such care and map the heavens in mechanical form, what other deep skills faded away with the centuries? Great Balls of Costa Rica. You step into a clearing and your feet hit smooth stone all around you. Hundreds of spheres lie half buried in grass, and some sit perfectly exposed like giant marbles. Most range from the size of a basketball to almost 2 meters across. Archaeologists date them to roughly 600 to 1,000 of the Common Era. They were carved from hard, igneous rock, and often finished with uncanny smoothness and symmetry. How did a pre-industrial people shape so many nearly perfect spheres with simple tools? Some suggest repeated pecking and grinding against a stone mold and patient polishing. Others note the uniform spacing and clustering near ceremonial sites and plazas. That pattern points to more than random craft. Some scholars argue they were status markers, arranged to mark routes or to align with the landscape. Others propose they were symbolic, perhaps representing stars or community members. Colonial-era clearing and later agricultural work destroyed many of them, which complicate study. Survivors show varying sizes and placement, which hints at regional traditions rather than a single factory process. Museum displays and satellite surveys reveal distribution that is both dense and deliberate. We have workmanship evidence and social context, but not a clear manual on how they were made so precisely at scale. If hundreds of expertly rounded stones were produced by careful, repeated labor and placed in meaningful patterns, what idea or social system drove that effort? Walk into an open field, and you notice something strange about the stones. Many are nearly perfect, with curves so smooth they catch the sun like polished metal. Tool marks tell a simple story of hard work. Craftspeople used hammering and grinding to shape and then polish each form. They selected tough rock and put in long hours of abrasion to get that roundness. Archaeologists mapped clusters and found deliberate placement near plazas and burial mounds. Some groups show tight rows, while others sit solitary on small hilltops. That variety suggests regional traditions and choices rather than a single uniform purpose. When Europeans cleared land and when later farmers plowed fields, many stones were moved or lost. The destruction makes it hard to recreate original layouts and original functions. Modern surveys, including overhead imaging, reveal dense sites that hint at planned arrangements across a landscape. Some researchers read them as status symbols, markers for chiefs, or elements of ritual space. Others imagine cosmological meanings, stars pinned to earth by stone. There is also the simple social answer. A community that invests patient labor into repeated craft shapes shows organization and shared values. Still, the evidence does not point to one clear use. We can see how they were made, and where they stood. We cannot read why they mattered enough to produce so many with such care. Were they a coded map, a tally of lineage, a statement of power, or a symbolic language now lost? Wow, signal. You are at a quiet radio telescope in Ohio when the printout spikes and a researcher circles the numbers and writes a single word that will not be forgotten. The year was 1977. For 72 seconds, a narrowband burst arrived from a patch of sky near Sagittarius. It matched a frequency that hydrogen emits, which makes the event stand out from ordinary space noise. That narrow focus is the strange part. Natural sources usually spread energy across wide bands. A tight signal like that looks more like a beacon than a storm. Scientists listened and found nothing else. They trained other telescopes on the spot for years and got silence. That non-repeat is the hard problem. If it was a transmission from an intelligent source, why only once, and why with no clear modulation or pattern? If it was a natural event, what process could make such a clean narrowband pulse at that frequency? Over the decades, many ideas surfaced. Some suggested a microwave transmitter on Earth reflected off satellites. Others pointed to comets or hydrogen clouds that might briefly amplify emission. Every theory has problems with timing, strength, or the exact frequency recorded. The signal was logged by Jerry Eman, whose note, "Wow," captured the shock and the unanswered question. Today, the wow. Signal sits in archives as a single bright mark in a quiet sky. It teases at the possibility of company in the cosmos. Or it points to a celestial phenomenon we still do not understand. Which of those two possibilities troubles you more? You go back into the archive and find years of follow-up attempts that came after that first printout. Engineers pointed other radio dishes at the same patch of sky over and over. They used different instruments with better resolution. They came up with nothing that matched that narrow burst. That silence forced scientists to test every ordinary explanation. One idea was local interference, like a stray transmitter or a passing satellite reflection. Engineers checked the equipment logs and environmental records and found no clear culprit. Another idea came from within the solar system. Some researchers proposed that a comet or hydrogen cloud could briefly amplify a signal near the hydrogen line. That hypothesis fits the frequency, but not the timing and strength recorded. Other scientists considered transient astrophysical sources that we still do not fully catalog. Each proposal explains part of the record and fails at another point. The honest conclusion is that we have a precise observation with no confirmed repeat and no consensus explanation. The label penned by the original researcher, that single word of astonishment, captured more than shock. It captured the honest gap between data and understanding. Decades of careful listening since then show how patient science is with mystery. And the mystery remains a neat question for the public too. If the signal was an intentional broadcast, why would it appear only once? If it was natural, what rare process produced that narrow, clear tone? Which possibility makes your skin crawl more? Company in the cosmos, or a cosmic trick we do not yet know? Tunguska event. You are in a remote taiga, and suddenly the night turns day as a falling light rips across the sky. Then a pressure wave hits, and trees lie flat for miles like fallen matchsticks. Scientists would later map an area of about 800 square miles, where the forest was flattened in a radial pattern. Survivors described a bright column and a sound like thunder that came from nowhere. When investigators reached the site decades later, they found shattered trees and burned vegetation, but no impact crater. That absence is the biggest puzzle. A meteorite strike usually leaves a scar in the ground. One leading idea is an airburst from a comet or stony asteroid that exploded high in the atmosphere. An airburst can release enormous energy and pulverize forests without leaving a deep crater. Another suggestion points to a fragment of a comet composed mostly of ice, which would vaporize on contact and leave little trace. There are also fringe ideas including sudden gas outbursts or unknown geophysical processes. Each explanation fits parts of the record and stumbles over other facts like the distribution of tree damage and local soil changes. Scientists use tree ring data and eyewitness reports to estimate energy and direction, but agreement is not complete. The event shows how a single moment can rewrite a landscape and leave a question that keeps resurfacing. If a blast can level hundreds of square miles and not leave a clear scar, how safe do we think our world really is from sudden forces we barely understand? Decades of study returned teams to the flattened forest with measuring tapes and drills. Scientists dated burned wood and tree rings to pin the shock to the early years of the 20th century. Those rings show sudden growth changes consistent with a powerful atmospheric blast. Researchers surveyed the pattern of fallen trees and found a radial layout pointing to an explosion above ground. Airburst models reproduce many details. Simulations of a stony asteroid exploding at high altitude match the radial tree damage and the lack of a deep crater. Comet fragments, made mostly of ice, fit the absence of heavy meteoritic debris because they would vaporize on entry. Field studies found tiny particles and chemical traces that some interpret as extraterrestrial dust. Other teams point to odd soil anomalies and magnetic changes near the site that complicate a single neat answer. The diversity of evidence makes consensus difficult. Every leading idea accounts for parts of the story and leaves other pieces unexplained. That scientific honesty is part of the point. We have detailed records, tree ring timelines, eyewitness testimony, and maps of destruction. We have models that can reproduce aspects of the event. We do not have a definitive airburst signature carved in stone or a clear cache of fragments that proves one hypothesis beyond doubt. So the Tunguska blast remains both a solved and an unsolved mystery. It warns us that powerful forces can arrive without a tidy crater to name them. If such a blast can flatten a vast forest and still leave room for doubt, what else can the Earth hide that we have not yet measured? Devil's Kettle. You stand on a rocky bank where the river splits, and one branch pours over a narrow fall into a dark, circular hole. The other branch continues downstream as a normal river. People have watched that hole for years because what goes in does not seem to come back out where you expect it. Scientists poured bright dye into the disappearing stream and waited below for the color to appear. They lowered cameras and sonar and listened for hidden channels with instruments. Those probes returned images of a deep, turbulent pool inside the hole, but no clear tunnel that leads out in sight. That lack of a trace is the mystery. Geologists point to porous bedrock and underground channels carved by ancient glacial melt as plausible paths. Others suggest the water goes into a hidden cave system or into fractured basalt that routes flow unpredictably. Some propose a deep sink or a submerged chamber that slowly filters water into groundwater systems. Every idea fits some observations and fails at others. If the dye should have reappeared downstream and did not, where did the water go and how long does it stay hidden? Local stories add a layer of folklore about vanished rivers that makes the place feel secretive and alive. We have measurements, tests, and careful surveys. We do not have a clear map showing the water's final destination. If a fast-moving river can vanish in plain sight and leave scientists baffled, how many hidden passages and lost flows remain under our feet? You watch teams at the riverbank running tests like patient detectives. They poured brightly colored dye into the disappearing stream and waited at points downstream for color to appear. They lowered cameras and used sonar to scan the swirl inside the dark hole. They measured flow, searched for hidden channels, and listened for the sound of rushing water far below. Those instruments found a violent, frothing pool inside the gap and rocky walls that drop steeply out of sight. They did not find a single clear tunnel that sent the water straight to the next visible river slot. Geologists examined bedrock maps and point to fractured basalt and porous glacial deposits as likely paths. Those formations can swallow surface flow and spread it into underground aquifers over time. Another idea is a concealed cavern system that captures water and routes it far from sight. Each explanation fits part of what the tests show and fails at other parts. If dye does not immediately reappear downstream, that could mean the water slows, filters, or mixes with deep groundwater before resurfacing. Local folklore and old maps hint that rivers shifted long ago, which adds complexity to modern surveys. The honest result of careful investigation is mixed data and no single airtight map of the flow. We have instruments and measurements and a better sense of subsurface chaos. We do not have a clear pipe connecting the mystery hole to a visible outlet. If running water can vanish into stone and defy our best probes, what else beneath the surface waits for discovery? Fermi paradox. You step outside on a clear night, and the sky seems endless with stars. There are more stars than grains of sand on any beach you have visited. With so many stars and so many planets, it feels likely that life should appear often. Physicist Enrico Fermi put that feeling into a single blunt question. Where is everybody? If life is common, where are the signs of other civilizations? Astronomers use a simple formula to estimate how many technological societies might exist. Even conservative inputs can produce hopeful numbers. Yet we have no confirmed contact, no undeniable broadcasts, and no colonies in our solar neighborhood. That silence is the paradox. Scientists offer several ways to resolve it. One is that life is rare, and the jump from simple chemistry to complex life is hard. Another is that intelligent life tends to destroy itself before becoming long-lived and visible. There is also the idea that advanced civilizations avoid contact, watching us like a zoo. Some suggest the distances are simply too vast, and light-speed travel or messaging is impractical. Others point to time. Civilizations may rise and fall so quickly that overlap is unlikely. Each explanation fits some pieces of the puzzle and fails at others. The honest truth is that we can model and guess and listen. We have not yet ruled out any major possibility. If the universe quietly contains many minds, or if we are alone, how would that change the way you imagine our future? You look up again, and the silence presses in. Scientists try to move beyond guessing by using a simple tool called the Drake equation. It lays out factors like star formation, the fraction of stars with planets, and how often life becomes intelligent. Plug in cautious numbers, and you can still end up with many possible civilizations. That is why the silence feels strange. One major idea is that life is rare. Simple cells might be common, and complex life very rare. Another idea is the Great Filter, which says something blocks most life from becoming long-lived or spacefaring. That blocker could lie in our past or ahead of us. Some theories say civilizations burn themselves out as they grow. Others suggest advanced societies choose not to broadcast and instead watch quietly. There is also the distance and time problem. Light speed makes travel and communication slow, and civilizations may not overlap in time. Scientists do not only speculate. Radio telescopes search for deliberate signals. Optical surveys scan for megastructures or waste heat. Searches for chemical signs in exoplanet atmospheres are beginning now. So far, none of these has produced a confirmed contact. The mix of models and patient listening shows how careful science treats big questions. We can imagine many answers. We can test some of them. We cannot yet claim knowledge. If the silence means we are alone, our choices matter in one way. If the silence means everyone hides, our choices matter in another. Which version changes what you should do with your future? Taos hum. You are lying awake in a small town, and a low vibration seems to buzz through the walls and into your bones. Only some people hear this steady low tone, while others notice nothing. The sound is low frequency and hard to locate, often strongest inside houses and hardest to record outdoors. Scientists and engineers visited the area and set up microphones and infrasound sensors. They checked for noisy machinery, water pumps, distant traffic, and power equipment. They tested for ground vibrations and for local industrial sources. Some teams used questionnaires to map who hears the sound and when. Those studies found that only a small fraction of residents report the hum, and that reports vary by location and time. Several explanations rose to the surface. One is local infrastructure like pumps or compressors that emit subaudible energy. Another is natural sources like distant ocean waves or atmospheric phenomena that create infrasound. A third is physiological, where some listeners experience tinnitus or other internal sounds that others cannot hear. Each idea matches parts of the record and fails elsewhere. Recordings sometimes capture low rumble, and other times yield only silence at the claimed moment. That mismatch between measurement and experience makes the problem stubborn. Beyond science, there is a human cost. Those who hear the tone report lost sleep, stress, and social friction when others do not believe them. We have careful surveys and instrument logs, and still lack a single clear origin that explains why only some ears hear the steady low tone. If a sound can be so real to some people and invisible to others, what does that tell us about the limits of our senses and the nature of reality? Investigators returned with better instruments and longer studies. They placed sensitive microphones inside houses and out in open fields. They used infrasound detectors that register frequencies below what human ears normally hear. Sometimes, the instruments logged low-level rumble at the reported moments. Other times, the recordings were silent, even when a person swore they heard the tone. That inconsistency is central to the debate. Engineers traced possible industrial sources like nearby compressors and distant traffic. They checked seismic records for ground vibration that could couple into house structures. Those lines of inquiry explained some reports and failed to explain others. Acoustic scientists looked at atmospheric effects. Low-frequency sounds can travel long distances and hide their origin. Weather, wind layers, and temperature inversions bend sound in odd ways. Medical researchers studied the people who hear the tone. They tested for inner ear conditions, tinnitus, and neuroauditory sensitivity differences. Some listeners showed physiological signs that make them more likely to perceive faint internal or external tones. Others had no detectable medical cause. The result is a patchwork of partial fits. Equipment sometimes captures a signal. Geology and infrastructure sometimes explain a local source. Human physiology sometimes explains perception without an external source. Add to that the social cost. Some residents lose sleep and face disbelief from neighbors. That social strain becomes part of the mystery story. We have more tests than when the hum first drew notice, and still no single clear origin. If a sound can be real to some people and invisible to instruments and others, what would it mean for how we trust our senses and each other? Voynich manuscript. You open a fat, old book, and the pages look like code written in an alphabet you do not know. The parchment of the codex has been radiocarbon dated to the early 15th century, which makes it genuine medieval material. Inside are strange plant drawings that do not match known species and detailed star charts with zodiac circles. There are recipes or pharmacy-style pages with little jars and roots drawn beside lines of the unknown script. Linguists, cryptographers, and curious amateurs have stared at those pages for more than a century. The manuscript surfaced in the early 20th century when a bookseller named Wilfrid Voynich acquired it and later lent his name to the book. Attempts to read it include frequency analysis, computational pattern searches, and comparisons with known alphabets. Some statistical studies show the text follows patterns similar to natural languages, which argues against pure gibberish. Other analysts point to inconsistent letter groupings, or to repeating structures that could be an elaborate cipher or a constructed language. A few researchers proposed it is a clever hoax, but the vellum age and the complexity of the drawings make that explanation hard to accept easily. Modern approaches use machine learning and multispectral imaging to reveal erased notes and hidden marks, but no translation has reached consensus. So we hold a readable book and no agreed meaning. If a book written 600 years ago hides its text in plain sight, was it meant to be secret? Or did an entire knowledge system simply vanish with time? You run high-resolution images across a page and find ink traces that the naked eye missed. Researchers used multispectral imaging to reveal faded marks and erased notes. They applied computational analysis and pattern recognition to study repeating groups and letter-like shapes. Those studies showed distribution patterns that look more like language than random gibberish. Machine learning teams compared the text to many known languages and alphabets and found some structural echoes, but no clear match. Paleographers searched for marginal notes and crude annotations that might give a clue to authorship. Some marginal markings resemble Latin letters, but the evidence is contested and too fragmentary to be a key. Scholars who support the cipher idea argue the text hides an ordinary language under a clever substitution. Others say it is an unknown constructed tongue used by a small community and now lost. A few propose the images and text form a practical manual for medieval herbalists or alchemists, written in an idiosyncratic shorthand. Skeptics point to the manuscript complexity and ask if a hoax could fool modern science. The problem is that the parchment age, the ink composition, and the drawing styles all match genuine medieval practice, which makes a simple hoax unlikely. So, the book sits between credible data and stubborn silence. We have advanced scans and rigorous statistics, and still no agreed reading. If a readable book from 600 years ago keeps its secrets, does that mean an entire knowledge system vanished? Or that someone intentionally hid an idea from eyes even then? Shroud of Turin. You hold a folded linen and see a faint, ghost-like image of a man with wounds that match crucifixion. The cloth is kept under careful guard in a cathedral and has drawn pilgrims for centuries. Scientific tests began in earnest in the 20th century. In 1978, a team examined fibers and surface properties and reported that no paint pigments were obvious and that the image sits on the topmost fibers. That observation means the coloring is superficial and not a simple applied paint layer. In 1988, radiocarbon dating performed by 3 laboratories dated the linen to the medieval period, which suggests a creation between about 1300 and 1500 of the Common Era. That result surprised those who saw the cloth as ancient. Critics later pointed to possible contamination and to the small sample location as reasons the dates might not represent the whole cloth. Other investigations looked at pollen grains and textile weave styles, and argued for older origins, or at least for complex history. Explanations divide into a few camps. One says an unknown medieval artist used a vanish technique that leaves no pigment signature. Another accepts the radiocarbon dates and sees it as a devotional creation. A third suggests natural chemical reactions or brief energy bursts might have caused the discoloration in a way we still cannot reproduce. Each theory explains parts of the evidence and leaves gaps elsewhere. We have careful lab records, contested dates, and an image chemistry that is stubbornly elusive. If a single length of linen can carry both devotion and deep scientific doubt, which part matters more to you? The historical origin or the meaning people find in it? Decades after those early tests, teams kept studying the cloth with newer tools. High-resolution imaging looked at the image at the scale of tiny fibers. Chemical analysis examined the faint discoloration for organic pigments or binding agents. Some studies found traces of pollen and dust that point to a complex history of handling and travel. Other teams revisited the radiocarbon result and argued that repairs or contamination could skew dates taken from a small sample. The debate turned on details that sound technical, but matter a great deal. If the dated corner included later repairs, then the medieval date might not reflect the original weave. If the image formed by a chemical reaction between linen and substances applied in antiquity, then the radiocarbon clock is still valid, and the image remains puzzling. Proposed formation mechanisms include deliberate artistic techniques lost with time and natural processes that alter fibers in subtle ways. A controversial idea once suggested short energetic bursts could change cellulose color without adding pigment. That idea is hard to test and hard to reproduce reliably. What keeps the debate alive is not only data, but meaning. Pilgrims and scholars do not step into the same conversation. For believers, the cloth is an object of devotion. For scientists, it is a test case in image chemistry and dating methods. For historians, it is a woven thread through medieval practice and trade. We have careful lab reports, contested interpretations, and a stubbornly elusive image. If a single piece of cloth resists a final answer, even after modern science probes every fiber, what do we do with a mystery that matters to both science and faith?